Okay, so today's notes are on function transformations, and our content objective is going to be to analyze function transformations, and our language objective will be to use the correct terminology to describe those function transformations, including horizontal or vertical translations, stretches, compressions, and reflections. So we're going to jump right in and make a table. So today's lesson is more of an overview of this stuff, and we're going to specifically apply it tomorrow to absolute value functions. And we'll do a little bit of that today, but I want to do the overview of what transformations are and the types of transformations before we go about applying them to absolute value. So first thing, we're going to make this table. It's going to have 3 columns. So bear with me. We're going to have horizontal up here. And this is going to be, or we're going to make a couple quick notes about this. It is horizontal affects the x value. So if you remember, our x-axis is horizontal, it goes left to right. So horizontal transformations are affecting our x values. And they're always going to be inside the function, and this will make more sense in a minute when I get to the actual application of some of these things. But just as a quick overview, horizontal is x values and they are inside the function, and vertical is our vertical axis. It's going to be our y values, and it affects outside the function. So those are just some key points or overview concepts before we jump right in. So the first type of transformation we're going to talk about is translations. So translations can be horizontal or vertical, but they will always be added or subtracted to our function. So translations are added or subtracted to our function. If they are horizontal, again, it's happening inside the graph, or inside the function. So it would be written as something like f of x plus or minus a. So it could be x plus a or x minus a, where a is some number. And it's going to move the graph left or right. So it moves the graph left or right, and it's going to do this in a way that's opposite what you would expect. So if you're adding a, you're going to move it in the negative x direction. If you're subtracting a, you move it in the right direction. So this is why I say opposite sign. So positive goes to the left, negative goes to the right. So I can even write that below here. So negative, positive, just so you remember that. So that's horizontal translations. We also have vertical translations. And again, since these are outside the function, you'd write them as the function f of x plus or minus a number a. So that would be our vertical translations. And it is going to move the graph up or down. So if we're adding a number, it moves up. If we're subtracting, it goes down. It's just as what you would expect. Adding moves it up, subtracting moves it down. We then have stretches and compressions. And I'm going to do these as 2 separate transformations, so they're very similar. So stretches are when you're multiplying by a number. And we're not going to worry about them. There are horizontal stretches, but we're not going to learn them in this class. I can talk about that some other time. So for this, it's again outside the function, you're multiplying. So it's going to be written as a number a times the function. And this makes the function narrower, or makes the graph narrower. So multiplying by a number narrows our graph. So if we have a number in front of our function, it's going to make it narrower when we multiply. And this is compared to compressions. And compressions are when we are dividing or when we're multiplying by a fraction or a decimal. So compressions are when you're dividing, which is the same as multiplying by a fraction or a decimal. And again, we're not talking about them for horizontal, so we'll leave that blank. So in this case, we still have vertical, so this could be written as 1 over a times f of x, or 0.a times f of x. So if you have a number between 1 and 0, or 0 and 1, so 0.a, so times some number, decimal that's between 0 and 1, then it's going to be a compression, which makes the graph flatter. So one makes it skinny, the other makes it fat. So this stretches make it narrow, compressions make it flat. And we have one more type of transformation we're going to talk about, and that's reflections. And this is when you make something negative or negate. So reflections are when we make something negative or negate it. And so for our horizontal, again, it's going to be inside the function. We're making our inside our function negative, so it'd be written something like that. And in this case, it's going to flip the graph over the y-axis. So the y-axis would be the vertical axis, and if you're flipping it this way, you're flipping it left and right. So it would be a flip over the y-axis would be a horizontal transformation. And conversely, our vertical would be the negative outside the function, and it's going to flip over the x-axis. Since our x-axis is the horizontal axis, if we flip over it, we're flipping up and down, which is a vertical reflection. All right, so this is the overview, and I know that's a lot of information and it's probably super confusing. So I'm going to break down sort of what we're doing with this with an example on the next page. So our example I want us to do today is to describe the function transformations. To f of x if g of x is equal to 3 f of x plus 1 minus 2. So we're going to look at this and figure out what transformations have been made to our original function to make this new transformed function. So our first step is to identify if the number is inside or outside the function. So again, outside is vertical and inside is horizontal. So when I'm deciding if it's inside or outside, I'm deciding if it's horizontal or vertical. So if I rewrite my transformed function right here, I know that this one inside is going to be horizontal because it is inside, so it's inside, and then I'll put that in parentheses. These two are vertical because they are outside the function. So when I say outside, I mean outside what's the f of x. So since those two are outside, they're vertical, inside is horizontal. And then I'm going to identify, or step 2 is going to be to determine the type of transformation. So again, adding or subtracting is a translation. Multiplying is a stretch. Dividing is a compression. And making negative is a reflection. So if I'm looking at these, the 3 is being multiplied. So I'm going to rewrite this again so we can see exactly what I'm looking at. So this is being multiplied. So I know it's going to be a stretch. These are both being added or subtracted. So these are going to be translations. So since those are both being added or subtracted, they're translations. So I know now if I'm combining these 2 bits of information, I'm going to now categorize my transformations. So here I'm multiplying, so it's a stretch and it's vertical, so I have a vertical stretch by 3, since that's the number I'm multiplying by. I'm going to have a in there horizontal translation. And since I'm adding it, I know I actually going to do the opposite, so I'm going to go 1, and it's going in the negative direction, so to the left, because positive would be to the right, so negatives to the left. I'm doing the opposite, so it's going to be 1 to the left. And then last but not least, I have a vertical translation down 2. So vertical translation down 2. So these are, that's my solution, that's my answer, and I've categorized all my transformations. So I'm going to do a quick check before we go. I want you to categorize the transformations to f of x given this function. So I want you to identify the transformations on your own. I'm going to go over it now. So if I start here, the negative sign tells me it's a reflection, and since it's outside, it's going to be a vertical reflection. So I have a vertical reflection because of the negative sign. The 2 here tells me, so now I'm looking at the 2, and that tells me, again, it's outside, it's being multiplied, so it's outside, it's vertical. And since it's being multiplied, it's going to be a stretch. And since it's just by the number that it is, it's going to be a vertical stretch by 2. Now I look inside the function, and I'm talking about horizontal, since I'm inside the function now. So I have horizontal, I'm adding or subtracting, so it's going to be a translation. And I'm subtracting, so I go to the opposite. Since it's horizontal, I'm doing the opposite. So I'm going 2 to the right. So horizontal translation, 2 to the right. And last but not least, a vertical, because I go back outside the function, it's outside the parentheses. A vertical translation up 3. So those are my transformations. I'm going to do one very quick example as fast as I can with absolute value graphs so that you get a quick intro to that before I finish these notes for today. So our example is going to be sketch the function y equals 2 x minus 1 plus 2 given the parent function f of x equals absolute value of x. So first thing I want to do, step 1, I identify my transformations. So step 1. So I know that this outside, if I rewrite my function, I have a vertical stretch by 2 because that's multiplying, it's outside the function. So now my function is the absolute value sign. So I'm looking outside of that, and I know the vertical stretches by 2. I have a horizontal translation because I'm looking inside the absolute value and I'm adding or subtracting. So it's inside horizontal, adding, subtracting, translation, and it's going to be 1. And since it's subtracting, it's going to the right. Last but not least, a vertical translation up 2. Because I'm adding 2 outside the function, so it's vertical translation up 2. Now, this applies to graphs because if I sketch the parent function is just the simplest version of a function. So we're sketching our simplest absolute value function, just f of x or y equals the absolute value of x. Sorry. So if I sketch this really quickly, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so my original function would look something like this because it has a slope of up 1 over 1 1 over 1. So my original graph looks something like this. Now what I'm going to do is apply these transformations to the graph and get my new function. So I sketched my parent function, and then now I'm going to apply the transformations. So what I do here now is I know my original function. I'm going to translate it horizontally 1 to the right. So I moved it 1 to the right. So I went here, and now I'm going to go up 2. So up 1, 2. So now I chose my vertex and I moved it, and now this is my new vertex. So my new vertex is right there, and now I'm going to apply my vertical stretch. So if my original function went up 1 over 1, I'm now going to go up 1, 2 over 1, up 1, 2 over 1, up 1, 2 over 1. And I'm going to do the same the other direction, 1, 2 over 1, 1, 2. And my new graph will look something like that. So if that didn't make perfect sense, our last step was to sketch new function. That's okay, we'll have a lot more practice with it later. As long as you're getting the first bits, you should be okay for class tomorrow, but make sure you write down any questions, comments, concerns you have so we can go over them together in class.